Good morning. Or, well, we'll see if it's morning. Good morning. First, weather report. Currently, as usual, I got this time about 5. Get a real late start this morning. Came out, turned the air conditioning on. Currently it's 7:57 and 89 degrees outside, 55% humidity. This morning I'm going to be working on, basically it's for the little generator, but this device, when I'm done, can be used with any DC power source up to, I believe, what are the specs on this thing? I guess I forgot it. Oh, wait. Nope. Oh, here it is. Okay. So what we have, I'll just start off with the components that we're going to use in this thing. I'm missing one component, and that component is going to be represented by this yellow piece of paper, which I've cut to the size that it is. It's on a slow boat from China. I ordered it over a week ago, and it's not here yet. So what we got, this is a DC to DC buck converter. This will take up to, if I remember correctly, 30 volts DC, and then convert it to almost any voltage. Unfortunately, I thought I had printed up the spec sheet and brought it out here, but I don't see it. Down to like just a couple of volts, but what I'm going to do is I'm going to set it to something like 14.4 or 14.2 volts DC. And the reason for this is that it's going to be very difficult to regulate the speed of the generator. Basically, I'll set it to a voltage above 14 volts and like maybe 16 or 18 volts, and feed that into this, which will then regulate output voltage and give me 14.4 volts for powering 12 volt devices or charging a battery. The neat thing about this is that when I'm done with it, it's portable. I can hook it up to anything. I can hook it up to a solar excuse me, a solar cell. I could hook it up to a car. I could plug it into a car cigarette charger or cigarette lighter outlet, and charge a battery. I could hook it up to any other 12 volt, anything, even 24 volts, and then use it to charge battery or power devices. So it's not a one-trick pony. The part that's missing is a charge controller, and what it is you set a voltage to start charging and a voltage to stop charging. Unfortunately, there's like no real information other than this, which says it can handle from 6 to 60 volts. although why it says max 80 volt battery, I don't know. But it just, all it does is it senses the voltage of the battery and then turns on a relay which allows the charge voltage to come through and go to the battery, and when the battery gets fully charged, it shuts off the charger, and it just repeats. It's really meant for like solar cells or something like that, but it makes for a great automatic battery charger, if you want to call it that. I have a couple of relays. I bought these for a different project, but that project I didn't go through with. I have a 10 amp fuse, circuit breaker. This button, it's an old AT power supply button that I've made it so it's momentary. I'm using this temporarily. This will control the starting of the generator until I get a momentary button. I went through all my buttons, and all the ones I have are either too small or they're normally closed, which won't work for this situation. This switch is going to be to control power to this, so that if I need to, I can leave the generator running, but I can manually shut off power going into this. It's going to have a 12 volt cigarette lighter type outlet, a light to indicate that the charger is powered, with a dropping resistor, because the light bulb in here is 12 volts and it's going to be getting 14 volts, and that will keep it from burning the bulb out. I have a small 30 volt voltmeter and a 10 amp meter. This system can only handle 8 amps. I can't remember what the max is on this. I think it's 10. The charge controller can handle up to 30. At least that's what the relay is rated at. I've got a small fan to help keep it cool, and some old-timey standoffs that I pulled from old radios or who knows what, for wiring stuff that can't be directly wired together. What else? I drew up, and I don't know if these are going to work. These are templates for these. This was interesting because when I was measuring these, I found out that the holes for holding this on or in place are not even on either side. They're offset. For some reason, somebody was lazy when they designed these things. So this is a template. And this is the circuit diagram that I worked up last night in a circuit, in a program. I don't remember the name of it. If someone asks, I can tell them. But it's for doing schematics. It's not the best program I've ever seen, but it's usable. So what we have here is a battery, which I'm going to use a small sealed lead acid battery, but any battery that's 12 volts that can turn over the motor will work. It only needs about 1 or 2 amps to get that motor running. A momentary switch. This momentary switch is going to be the starter button. So the way this is set up, nothing should be powered unless this button is pressed, and this is only to engage the relays for starting the generator. Otherwise I can start it manually and I don't even have to push this button. So what this will do is, these two are relays. Excuse me. This one is the starter relay. It's just one of these. And this one is the relay that controls voltage to the buck converter. This relay will be normally engaged, so when this button is not pressed, this will have power, and this button, when this one is pressed, the voltage, or the battery output, the voltage output from the charge controller will be shunted to the battery for charging it. One thing I'm going to have to check and see is if there's a, there should be, since this is a relay, if there's no power to this or this, then voltage from the battery will not get back into the system. So the way this works is you press the button, this relay is engaged, this line moves down to here, power comes in from the battery, goes out through this contact into the motor. It also goes down here, but this will be engaged and it will go down here to no contact. So it cuts off power to this while it engages power to the motor. So then the motor's turned on. The motor then starts the generator. Once the generator is running, you let go of this button. This one pops back up here to its normally closed position. Power goes out. Power is then routed from here into the battery. This one, power from the motor, which is now a generator, once it's started, goes in here through a fuse, or actually I put a fuse, but it's a circuit breaker, through the switch, into the DC buck converter, out the DC buck converter, to a load with a load indicator light, and I believe that's what that red light is going to be for, and then to the charge controller. And if the battery has been depleted by starting it, the charge controller will recharge the battery. And like I said, this can be used to hook up to any battery system. It's just that if you were hooking it up to a regular battery and you were using a solar panel, you would never engage this button. If you did, nothing bad would happen, but there would be no need for it. That's basically it. What you'll get out of here is 14, whatever I set from here, and then that voltage will also go through here to the battery. I'm debating, I may take an output from the motor and output it raw to some posts, just to get, you know, voltage straight off the generator. But I don't know if I don't know yet if I'm going to do that. So I'm going to stop this video here, and then, because I'm going to post this video separately, and then I'm going to start up another video with the actual work that I'm going to be doing on it.